Hey all, so in today's video we are going to talk about System Verilog overview. I am going to give you an entire view on what is System Verilog, what are we going to learn in System Verilog, and what are the enhanced topics in System Verilog compared to that of Verilog. So all these things we are going to discuss in today's video. So coming to the introduction of System Verilog, this is basically considered as extended version of Verilog. When you go to see the Verilog, Verilog is basically called as an HDL, which is hardware description language. But when coming to System Verilog, that is considered as HDL as well as HVL, which is hardware description and hardware verification language. So that means this System Verilog is mainly considered for verification, developing test benches which are related to verification department. So that is why System Verilog is mostly adopted by many companies for as a verification medium. Why? Because as I told you in the starting itself, System Verilog is having many extended features. Like it is having it there were many extended features in System Verilog which were only introduced in System Verilog, because Verilog doesn't contain these features like oops, assertions, coverage, constraint randomization. So these all were the features that were introduced only in System Verilog. In Verilog, you don't find any of these features, which is why by using all these features, we are making the System Verilog most adaptable option for verification, right? So these are certain features of System Verilog like constraint randomization, oops concept, functional coverage, assertion, synchronization, and improved data types. So in Verilog also you will have the data types, but apart from that data types there were many more other data types which were introduced in System Verilog. Similarly, oops is not present in Verilog. When it comes to synchronization, synchronization is nothing but the synchronization between test bench and DUT. The way that System Verilog is useful for synchronizing this test bench and DUT is far more better compared to that of Verilog. Right? So these are some of the advanced features in System Verilog which makes it the only option for verification. Right? So now coming to test bench architecture. If you see this test bench architecture in Verilog, you don't find any test bench architecture. When you are writing a code in Verilog, when you are designing something using Verilog, basically you will write only a test bench code where you will be passing the values in a module format, and in design you will be writing your logic. So basically there are only two things, which is RTL code and the test bench code. From the test bench code you will be passing the values to your RTL code, and you will be verifying whether your particular logic is correct or not, basically. So this is happening for Verilog. But the main thing in System Verilog is used in order to verify the complex circuits. When it comes to complex circuits, okay, Verilog is not sufficient for verification, which is why System Verilog test bench architecture was introduced, in which there are lot of components like generator, monitor, driver, scoreboard. So all these things, based on all the synchronization of all these components in this test bench architecture of System Verilog, you will be easily verifying the complex designs also in a time limited, in an small in an less amount of time you can easily verify complex designs also by using this test bench architecture of System Verilog. So this is the test bench architecture of System Verilog. I'm not going to explain deep about this test bench architecture, because once we get into deep into the topic we'll be knowing about all these things. Since today is an overview, I'm just going to tell you what are the concepts that you are going to learn and what are the things that are actually present. Right? So this is the test bench architecture. Then coming to data types. Just before we have talked that in system Verilog, we are having many other data types which were included in system Verilog compared to that of Verilog. So basically, in system Verilog, there are two kinds of data types which are user defined data types and predefined. So basically, predefined means again it is categorized into structural data types and behavioral data types. So structural data types means register and wire. You know in Verilog what is this reg and what is this wire. So I'm not going to explain again anything about this. And when it comes to behavioral data types, you have seen the int as well as real, but the integer was introduced here. Okay, not int. You have only seen int in Verilog, but in system Verilog you will be finding this integer, real, and the one more thing is time. In order to know the simulation time, you will be using this time data type. And along with that, there are many user defined data types. User defined means you yourself can define a data type in system Verilog. You can have that probability in order to you can have the chance of defining a data type. There are lots of ways in order to define the user defined data type, like you can use enum keyword in order to define a data type, or there are parameters. There is logic was introduced in system Verilog. Logic is nothing but it is the combination of rich and wire. Like whenever you want to use the rich data type, you can just use logic. Similarly, whenever you want to use wire, you can use the logic instead of wire. Like why is this was introduced, we'll be talking deeply when we enter deep into the topic. So again, void, string was also introduced in system Verilog. So these are the different data types which were introduced in system Verilog. Okay, so this is about the data types. Next, coming to types of arrays in Verilog, system Verilog. So arrays, you have already seen about arrays in Verilog, but in Verilog you have just talked about what are arrays, like fixed size of arrays. That's it. But in system Verilog it was extended to a lot more. Like in system Verilog you are literally having three kinds of arrays. One is fixed size array, which you have already talked in Verilog, and then the dynamic arrays, associative arrays, and queues. Okay, arrays is very important topic in system Verilog, because whatever you want to whenever you want to give a group of variables to a particular group of values to that particular variable, you will be only using arrays. So basically you are having three options compared to that of Verilog in system Verilog, right? So those are these things like static arrays, dynamic arrays, associative arrays, and queues. And these are about what how are their syntaxes, what are their methods and all. You can just have the view, but if you want this, once we enter it deep into the topic, you will be knowing what are these kinds of things, right? Now, the next thing is system Verilog processes. This is also very important concept in system Verilog. Basically, process is nothing but we already know, we have already talked that we are verifying a complex test benches. So we are developing the test bench in order to verify the complex circuits. So basically when we see about the complex circuit, we will be having lots of modules, is it or not? So every module consists number of processes. So every process will be running parallelly. So what happens when all these processes are running parallelly, there may occur a situation which is race around condition if we don't follow a particular rules and regulations while we are running these processes. So in order to avoid this race around condition, and in order to make the simulation of this particular flow in a process, we are using the system Verilog processes concept. So in this processes there are three kinds of processes basically, which are fork join any, and fork join none. Okay, here each process like fork join is different from fork join any, fork join any is different from fork join none. Okay, we'll see about this once we get deep into the topic. But in system Verilog processes we are going to learn like these three topics, right? And then now coming to advanced features in system Verilog, which are, the first thing is oops concept. Oops concept is nothing but entirely based on classes. Okay, so what is this class? Basically, in Verilog, if you see, you will write everything module based. Is it or not? So when it comes to modules, modules are not dynamic in nature, they are static in nature. Okay, but when it comes to classes, they are dynamic in nature. So what if it is static in nature and what if it is dynamic in nature? As I already told you, system verilog is used in order to verify complex circuits. So when it comes to complex circuits, basically when you want to design a complex circuit, the most important advantage of system verilog is reusability property. Okay, that reusability, that means we will be developing the test bench by using this reusable properties. So this reusable properties will be coming from classes. Okay, classes is having four important properties which are inheritance, polymorphism, encapsulation and abstraction. So with the help of these four properties within the classes, classes will become dynamic in nature. So if you see in the test bench architecture, just before we have talked about the test bench architecture, so in this, every component like generator, driver, monitor, scoreboard, so everything is class based. Okay, so that means everything can be reusable, every code can be reusable. So because of that, we are saving lot of time in order to create a new code. Okay, so that is why, since classes are dynamic in nature, mostly we will adapt classes rather than modules within our system Verilog, right? And then coming to the second important feature in system Verilog, which is randomization. Okay, so randomization, generally in Verilog also you have seen this like dollar random and dollar u random. But since we are using classes, basically in classes we'll be having objects. So in order to randomize those objects, this dollar random doesn't support this particular class object randomization, which is why the randomization concept was introduced in system Verilog, which is far more better compared to that of Verilog, right? So again in this randomization, in order to put limits on this randomization, because since we will be developing complex circuits, so basically we will be giving a very high number of bits. So when we are doing randomization on that high number of values, like a high number of bits, basically we need to put limitations in order to have our requirements. In order to give get our required values, you need to put the limitations. So just like constraint randomization is nothing but putting limitations on the randomization in order to get our specific value. Okay, so this is about constraints. Basically randomization and constraints both goes one in one. Like constraint, first you will see about randomization and you will be knowing what are how to put the limitations on that particular randomization bits. Okay, so this is constraint randomization. And the next important feature in system Verilog is interface. Basically you don't see this interface in Verilog also. So interface is nothing but it is a bundle of wires. Basically whenever you are driving input values from test bench to DUT, you will be driving some stimulus, you will be driving some values. Okay, so in order to drive those values from test bench to DUT, you will be using this interface. It is nothing but kind of bus you can see. Okay, which consists of some bundle of wires. Okay, so generally those values which you want to put from test bench to DUT, you will introduce all those variables within your interface. Okay, that is the simple version. Again within this interface you will be having the virtual interface concept. You will be seeing that also in deep once you get deep into the topic, right? Then comes the one other key feature in system Verilog, which is assertions. Basically assertions means we are checking something. For example, when you are designing, when you are verifying the design, you need to know how the design is behaving. Okay, you what are you verifying? Basically you are verifying whether the design is behaving in the way you want. is it or not? Whether when you are passing some stimulus to that particular design, it need to behave. For example, when you are designing an adder, when you are passing the stimulus like 2 and 2, it should respond to 2 plus 2 and it should give you the output as 4. So in this way, whether the behavior of the circuit, whether the behavior of your design is correct or not, you will be writing some assertions for that in order to know whether the circuit is behaving correctly or not. You will be giving some specific condition or some sequence of events, and you will be checking whether it is particularly behaving in that way or not. Okay, so that is assertions. Again, in assertions you are having two kinds, like immediate assertions and concurrent assertions. Okay, you will be seeing once you get deep into the topic about these assertions. Then comes the important topic, which is coverage. So coverage means basically, okay, for example, I am designing some 3-bit adder. Okay, some 3-bit adder means how many amount of stimulus you will get, so 2 power 3, which are 8 number of inputs you may receive. So this coverage will consider whether all these inputs are properly received, whether all the cases are covered or not, whether all the 8 cases are covered or not, or basically, so entire coverage, like whether every scenario, every stimulus has gone to the DUT and DUT is responding correctly or not. In this way, the entire thing, like all the stimulus, because you will be, when you are designing complex circuits, basically you will be checking every component, right? So whether everything, every scenario is done. For example, when you are checking the memory, you will be seeing the scenarios like whether the read operation is done correctly or not, whether the write operation is done correctly or not. In this way, you will be having many scenarios. So this code coverage or function coverage, it will be checking whether all the scenario stimulus has gone to the DUT and whether the entire work is done properly or not. You will be checking it through coverage, right? So this is about coverage, right? So these are the topics that you will be seeing mostly in coverage, right? So this is the overview of your system Verilog. These are the concepts that you will be learning in your system Verilog, right? So this is about all, and apart from this, you will be also learning how to develop a test bench. Like we'll be taking some small example like memory or else adder, and we'll be developing the test bench code on that particular circuit, right? So this is all about the system Verilog course that you are going to learn. That is all. Thank you.